this week, and thanks for putting up with our technical difficulties. Luckily, Brenda worked her magic, and she just touched it, and it seemed to fix itself, so that is really great. And I'm really happy to introduce Tim Bruckner, who's here at UCI in the departments. He's a joint appointment in the Department of Public Health and in the Department of Planning, Policy, and Design, and he's going to talk today on intrauterine stress and male cohort quality, the case of September 11th, 2012. So welcome, Tim.
2001.
Oh, 2001.
Sorry.
In the future.
Thank you, Kristen. I want to make a brief kind of advocacy plug for population centers in general, because I think this type of work comes through collaboration of different departments, and I benefited from working with Jenna Nobles, who was a Robert Wood Johnson scholar at UC Berkeley at the time, and we would not have come across each other's paths given the types of research we were doing. So I think that the CDASA program and this Population Society and Equality series is really invaluable for cross-pollination. So to get started with this talk, for the demographers in the room, I want you to think about a life table across your whole life. All right? And so what year from age 0 to 50 is the year where we have the highest mortality rate? 1. 0 to 1, right? Okay. So, so the infant mortality rate in the U.S. right now is about 6 per 1,000. And that rate dips down age 1, 2, 3, 4, age 13, the healthiest year of your life, about 1 death per 1,000 children age 13. Then it starts going up, and when you're after 35, you have the Gompertz, right? This exponential increase every 10 years until around age 55, when your age-specific mortality is about that of infancy. All right, so you kind of have a bathtub, right? High infant mortality rate, down, back up to 55, and then all the way. So I want to take a step back from even infancy. I want to go back before infancy. Right? So from pregnancy, from conception to birth. All right? You guys are really lucky because you're a select few that made it. But between 50 to 70% of all conceptions don't make it. All right? For the amount, that force of loss approximates the age-specific death rate of a 105-year-old. Because about 50% of 105-year-olds don't make it to 106. All right? So there's a huge amount of selection of individuals from conception to birth. Judy?
Is this unique to the species, or is this
this amount of loss is not unique to humans. No.
Okay.
Most of this loss occurs before pregnancies are even detected clinically. Okay, so a large fraction of this loss occurs in the first couple of days, but you still have a large amount of loss over the course of the first and second trimesters, less so in the third trimester. And despite what obstetricians might tell you, which is, we know what causes this. We know it's chromosomal abnormalities. Isn't it all just, trisomy, this, that? Those are the causes. Even if you accept that these chromosomal abnormalities cause fetal loss, it might only account for about 50% of overall losses. So still a large fraction that remains unknown in terms of its etiology. And of those chromosomal abnormalities, still, there's a lot that get through, right? You have muscular dystrophy, Down syndrome. So it's not that a chromosomal anomaly necessarily determines your fate, all right? There's a lot we don't know about the course of pregnancy and what might lead to spontaneous loss. In this context of a large amount of losses, you have what I call male vulnerability. And unfortunately, it's not just confined to pregnancy. We know men are screwed right when they're born, right? Less than 6 years, 5 to 6 years lower life expectancy relative to females. We have in utero about 50% more male losses than female losses. So the estimate is between 1.2 to 1.5 males per female conceived that is lost. All right. This cause of male-specific vulnerability is also largely unknown. Okay. So, what are some evidence that we have outside of the animal literature of male-specific sensitivity in utero? One way we begin to gauge this sensitivity is we look at sex ratios following population stress. So the sex ratio is essentially the amount of live male births divided by the number of live female births. In the United States, it's around 1.045. So more males born than females, but only a small amount more males than females. And when we see demonstrable population stressors, there's often a response in terms of a declining population sex ratio. And the presumption is that there are fewer males being born than you otherwise would have expected had that population stressor not occurred. And this observation occurs across a wide amount of places and times. A lot of work that I've done with my old advisor at Berkeley, Greg Catalano, we look at economic contraction. We've looked at September 11th in the United States and California. He looked at the unification of the two Germanys, and being born in Leipzig, in East Germany myself, and having relatives who lived there. That was one of the most stressful periods, actually, the unification of East and West Germany for East Germans. Earthquakes in Japan and in Chile, the dioxin spill in Seveso in the 70s, a variety of other things. So we see, following population stressors, an increase in the ratio of male fetal deaths to female fetal deaths. And also, a corresponding decline in live male births relative to live female births. Okay? So there seems to be some fetal loss mechanism that preferentially affects males that affects the sex ratio. And then if you look at animal models, there's some information about corticotropin releasing hormone sensitivity among male more than female fetal sheep. So fortunately we don't do these experiments in humans, but for animal models that we have, the sheep is an interesting case because its trimesters are similar to human trimesters, so that's why we use the sheep and not the mouse, for example. So we see that there is some physiological mechanism that might lead to increased sensitivity of males in utero. Now, in addition to these observations, evolutionary scholars have weighed in as to, and taking a step back, as to thinking, why would there actually be a cause in this variation in the sex ratio? So moving away from the mechanism, I mean, what's the ultimate reason? Why would we have the conservative mechanism to do this from a population perspective? And the idea, brought up by Trivers and Willard in '73, this article has been cited over 1,100 times since its publication, so one of the most heavily cited articles in the last 50 years. They argue that natural selection has conserved mechanisms by which pregnant mothers might selectively abort males if there is a low likelihood that that male, if they're carried to term, survives and reproduces. Right? So the notion is, if I'm faced with a resource-constrained environment, I don't want to produce a male that might have limited resources and have low prospects of actually surviving to reproductive age and reproducing. Because if I did, there's so much energy that I invested in the individual and it didn't yield my grandchildren. Now, why would that be male-specific? This gets at this notion of the fact that females who were born into frail environments have relatively better reproductive success than frail males. So in a resource-constrained environment, let's say if you're a red deer, so taking it away from the human example, here's a red deer in Scotland. A lot of the sex ratio work's done on red deer. And they look at a cold winter. The reproductive success of a female born in a cold winter is much greater than the reproductive success of a male born in a cold winter relative to other males born in other years, right? So you have to think of the relative advantage. And essentially, males are at that reproductive disadvantage. So if you can conserve a mechanism that in utero spontaneously aborts potentially weak males in times of stress, you can then maximize your chance of investing in your own other offspring or reproducing yourself. Okay, So that is the kind of bird's eye evolutionary view of why the sex ratio would vary. Now, if we have an environment that is perturbed, so we're marching along, we have a sex ratio of 104 males to 100 females, and then, oops, we have a stressor, say exposure to dioxin, very toxic chemical. And we can imagine a variety of responses. And what we call here in one of our papers is called this shifting distribution versus shifting criterion model. So I'll walk you through it. First, look at this top panel A. So the dashed distribution of gestations, or male gestations. And the x-axis is this survivability. You could think of it as fitness or some index of the ability to survive and reproduce. And there's a distribution. You have individuals, gestations that might be terminated because they lie to the left of this dotted, vertical dotted line. So they're below a maternal criterion for spontaneous abortion. They wouldn't yield offspring if they were brought to term. Okay? You have distribution. And you similarly have a distribution for females. That is right shifted. Again, females are just better off. Okay? Higher likelihood of surviving to birth. Now this is a normal environment, but what if you induce a stressor? And we observe that the sex ratio changes. You could have one of two circumstances, or many, but I'll just propose two. First is that you have this stressor that's not only leading to loss in utero, but also damaging those that actually survive to birth. And so what that implies is you're actually shifting the distribution of both female and male gestations to the left. They're becoming less fit because they're subjected to a stressor. The sex ratio still declines, right? Because there are more males that disproportionately lie at this end. Sex ratio still declines. Now how about panel C? Same stressor. But now, instead of shifting the distribution of survivability but for males and females, you're shifting the maternal criterion. So that mothers are now more stringent in who they allow to survive through gestation. And when I say who they allow, I'm thinking of an autonomic process, right? This isn't volitional. Okay. The sex ratio would still decline. So following a population stressor, you would still have, in either of these situations, a reduced sex ratio. But the implications of on the health of survivors is fundamentally different between the shifting distribution and the shifting criterion model. You could think of this as kind of like damage, right? Cohort damage. There was a stressor in utero. It affected all of us adversely. Some of us didn't make it, and those that did make it still have a scar. In contrast, this might have selected out individuals and been more stringent. So the cohort that survives is smaller, but on average healthier than they otherwise would have been had the stressor not occurred. Right? And the huge damage is in all of the excess fetal loss. All right? So that is a rather oversimplified schematic of what might fundamentally occur in these populations. Now, these hypotheses provide testable propositions. Because if you look at the relationship with the sex ratio and health of the survivors, you can distinguish between these two. If high sex ratios, more males, lead to higher morbidity among those surviving males, that would support shifting criterion, right? Or alternatively, fewer males born would lead to a smaller but healthier set of males. In contrast, if high sex ratios were positively associated with lifespan, you would support the shifting distribution model. Okay? So what we essentially have found in a variety of places and times is also that the evidence on the whole seems to support culled cohorts. We have evidence that the lower the sex ratio, the longer the lifespan for males. Sweden, Denmark, Norway, looked in the historical populations because you have to actually go back historically to get cohort lifespan, right? So you can only look at people that were born until 1916 because not enough people in 1917 have died yet, which is fine, which is good, but you can't estimate their completed lifespan. Also, contemporary populations. So we looked in California. Male infant mortality varies positively with the sex ratio. 1989 to 2004 in California, monthly. All right, so given this information, we might think that population stressor could induce, on average, a smaller but healthier cohort. Now this comes up against what you probably have heard of. So I'm going to guess that most of you haven't heard of most of what I described. But you sure know this literature, which is developmental origins of disease. If you're born very low birth weight, you have a worse off chance to live, to graduate from high school, to have a variety of beneficial outcomes. There are critical periods of development. And so to the extent that you're exposed to toxins, maternal stressors, low nutritional environment, air pollution, you could then, it could affect your lung development, your brain development, your metabolism, all of these factors that over the course of your life could yield adverse effects. Okay. David Barker first popularized this notion, and much research focuses on this, and there's a very strong evidence that also supports cohort damage. Okay. So, thinking of these two mechanisms, cohort mechanisms. Now I'll talk about the case of September 11th. So, I'm sure we all remember where we were when 9/11 occurred. It was a very severe stressor that affected not only kind of social functioning, but also the economic circumstance in the United States. The stressor was obviously not confined only to the area of the attacks. So my colleague Greg Catalano has coined this term communal bereavement, which is essentially we grieve for people we don't know. And this phenomenon occurred not only well before 9/11, but also the assassination of the Swedish Prime Minister in the 90s, death of Princess Diana, and others. And so there is a strong kind of psychosocial response to 9/11, in addition to if you had an immediate relation who died in the attacks. Again, so this anxiety is pervasive. Post-traumatic stress disorder in nationally representative samples shows elevated incidence. So how did it affect the sex ratio? We have, in New York City, 5% fewer live births than expected in January. So 4 months after 9/11, I didn't have fetal death data on this, so I only looked at live births. We had the sex ratio falling below 1. Now, it might not seem like, 5% might not seem like a large drop, but for a large population, like New York City, this is humongous.
I'm sorry, how many months after? 4 months?
Yeah, 4 months. Okay, so for January 2002, that. The sex ratio is a mean reverting system. So Fisher actually used it, the sex ratio, to derive a lot of statistics because of its mean reverting properties. So this is basically, boom, this is so stable over time for large populations. So a 5% drop is rather large. All right, and in California, we had a smaller effect, still significant, 2% fewer live males than you'd expect. The timing was a little different. This was in December. And so that was 3 months after. And this was consistent with when I looked at fetal death and very low weight sex ratios. So I'll show you here these last 4 points. So in September 2001, this is the incidence of the sex ratio of fetal loss. And then the male fetal loss increases here in November, and these were statistically significant. Okay? And the very low weight story is similar. So if you presume that those that were on the cusp of that criterion, so the fetuses that might have been right at the edge, those fetal losses, maybe had they not been lost, maybe they would have resulted in being very low weight. They would have been fragile anyway, but they would have survived to birth. The very low weight sex ratio went down dramatically coincidentally with the fetal death sex ratio going up. So it seems to be there a compensatory effect, essentially.
Would you expect it to be further out? I mean, that's a loss at 6 months gestation. And you'd expect a lot of the culling to happen earlier, right? Which is when 80% of pregnancies are terminated.
Right, good question. Yeah, so I think there's a couple things going on. So we're looking particularly at male-specific sensitivity, in which the hormones might kick in. That sex-specific sensitivity, to the best we can detect, occurs in the second trimester. So the timing, and so we don't really know if there's male-specific sensitivity earlier than the second trimester. We haven't detected that in experimental animal models. Not we, I mean the field. But the second thing is data. So it's very hard to get data on fetal loss before the 20th week of gestation.
Right.
So there is, to the extent that you can get it, the sex might not be accurately indicated. And so fetal death after 20 weeks, which is the data that we have, I should have mentioned that, we think that there's dramatic underreporting, but not by sex. So we look at the sex ratio still saying that's an accurate depiction of the population of fetuses that were lost, but not of the number, because we know it's just the tip of the iceberg. That's good. So, Katie?
This over time is just showing the various perturbations, and so I was wondering, you see other spikes in there that are similarly high.
Yep.
So.
Yep. What's up with that?
Yeah.
This is the time series, the age-old time series thing. I don't have an a priori, so I didn't look.
Okay.
Because that would kind of be cheating. But I could tell. I mean, I could stipulate. Maybe it's economic change. Maybe there's some stochastic variation. We looked at fetal death sex ratios after economic change, and there's a strong relationship with that. So there might have been some other components, some ambient factors that might have led to it. I should say that there are much smaller numbers in the fetal death sex ratio in California than in the overall sex ratio of live births. So we're talking about probably 400 fetal deaths per month that we're observing. So each of these time points is kind of encapsulating only 400. So you have more stochastic variability than, say, 40,000 births, which is what we have in California per month. All right, so why would California be affected by 9/11? Right, so we looked at California because we had data, frankly. That's because I was working on the perinatal profiles project in California. We looked a little closer as why California would be affected. Its economy relies a lot of it on tourism. And tourism, if you recall, is one of the biggest industries hit. And there was a very acute reaction. About 30%, so more 9/11-related mass layoffs than any other state. Tourism suffered about 30% decline in those 3 months. Okay, so there might have been kind of a ripple effect of 9/11, not on the social component, but the economic component that would have induced stress. The other thing is, there's a lot of social connectedness between New York families and California families. Second to Florida. So the most connectedness that New Yorkers have to any other state is Florida, because that's where they retire. But the second state is actually California, in terms of where people migrate based on census information. So there is some sense of social connectivity transcending geographic space.
There was also a lot of talk that Los Angeles might be targeted, right, around that time.
So, right, and that's the part I don't remember as much, but if that could also...
Or maybe, I don't know, maybe that was later. But people were talking about Chicago and Los Angeles, right?
Yeah, you're probably safe in Nebraska.
Right.
But I can't remember the timing of when.
Yeah, exactly. When exactly did that rumor hit? So I don't know. So this is all by way of background. But now that I've given you sufficient background on this culling and damage, I'm going to cut to the question, which is right. Yeah.
So one slide back. One slide back.
One slide back from this.
I know. So that's not very impressive. If you look at all the fluctuations, right? There are any number of events that happened before that I could say, "Oh, that's an event that caused this kind of fluctuation."
Right. So the first thing that I was trained when I did my time series was that your eye lies.
So are you?
You can
saying
see
my
patterns.
eye line-
That's great. You have great glasses, and I respect you highly. Your eyes line. So the notion that we can see, so we see associations when there are none, and we can identify patterns. The notion that we can identify patterns. There is a huge amount of patterns in here. There's seasonality. There's September seasonality. So I have to remove the effect of seasonality before I derive the expected value of fetal loss. So the expected value of fetal loss in October 2001 is not the mean. The expected value could be potentially here. Okay, and in fairness, I agree. I mean, there's a lot of variation, and you could say, oh, and we can make a lot of post hoc speculation about what caused what and this and that. And I think that in terms of parsimony, it rests on what are your priors, and what is the strength of the theories, and what is the the rigor to which you can subject this to a kind of a statistical test in terms of deriving an expected value.
So your null model has a sinusoidal trend or indicators for months? Or
This is an ARIMA, so autoregressive integrated moving average. So I include both autoregressive components and moving average, and it's not integrated, so there's no non-stationary mean. So it's using the kind of Box-Jenkins forecasting methods. I wish I could be more impressive to you, but
Don't we all?
I could be that Netherlands guy who doctored his data. All right, so the question I have about 9/11 is, well, great. So we've looked at kind of infant mortality, but what about these kind of, what if I can measure fitness, right? Isn't that the criteria on which mothers are selecting fetuses? How could I gauge fitness in a population? Measure them over time and say, okay, these males are better or worse off than they would have been had 9/11 not occurred. And that's kind of where I got to talking with Jenna, who has worked thoroughly with the ECLSB data, so the Early Childhood Life Survey cohort of 2001, where they have a variety of information on child development of the cohort. And so she said, oh, we can look at, there's some correlates of fitness. They're not perfect in the modern day and age because some women choose not to reproduce, right? There's so much, we can't look at completed fertility or that, right? It doesn't make sense anymore in this population. But if you don't live until you're 18, good chance you're not going to reproduce, right? So there's some kind of clear benchmarks of fitness, but also strong predictors of health and wellness over your life. So I picked two, and I looked at the literature first because the ECLSB has tons and tons of variables that I could have looked at, but I chose to be most consistent with the theory before I started fishing with 40 or 50 correlates of health. And I focused on the Bailey Cognitive Score and height. So two correlates of fitness, I would argue. The literature says it's strongly related to health and wellness over your life course. And what I looked at is, well, did male infants born to low sex ratio cohorts after 9/11 exhibit a different health trajectory? Do they exhibit a positive health relative to their expected value? That would support culling or more selection. Or perhaps a negative, right? A damaged phenotype. And that would support more cohort damage. So I used the ECLSB data set, which covers the cohort in 2001. That is important because I couldn't look at New York City, right? I would have loved to look at the place where the highest amount of presumed fetal loss occurred among males. But that was in January 2002. They didn't follow them up, or at least the ECLSB didn't. And if you know about the data sets that do, then we will talk afterwards. I do not. So ECLSB is nationally representative. It enrolled about 11,000 children born in 2001. Longitudinal cohort study. And at the time that I tested it, they had a 9 and a 24-month follow-up. Now they have kindergarten as well. And they have trained staff. The measurement properties of a lot of these tools are highly valid, vetted. So I'm not going to talk so much about how Bailey is measured. We can push through that, and then if you have questions, we can talk about it in the discussion. I have a lot of text here, but essentially, these tests have been done over and over in terms of the validity, inter-rater reliability, repeatability among individuals. The key point is that a low Bailey low cognitive ability. It predicts all-cause mortality, substance abuse, cardiovascular disease, and diabetes. And that's just a short list. All right? And they base this Bailey score on children's ability to do various tasks. And they say, well, what could you do in two years that would gauge cognitive ability and be so predictive? They're not asking you to do calculus. It's just putting cubes in a cup, responding to a spoken request like, hey, can you shut the door, please? Or retrieving a toy. But it's not just those three. There's a wide scale that allows you to come up with a Bailey cognitive measure. Also, I use height. And there's also validated ways to measure height. I standardize it to the World Health Organization scale to come up with z-scores. And essentially, the taller you are, the lower your mortality. Okay, so that's a general observation across both males and females, across a variety of societies and times. And this gauges early life growth, and it also predicts subsequent educational attainment and also adult lifespan. So those are the two that I chose. And the method that I used, it's not a typo. This is actually what they call it. They call it Diff and Diff and Diff. All right? And it's essentially a difference in difference estimation strategy. And I'll go through it briefly. It's increasingly used outside of economics to look at child development and perturbations in development. And the key idea is that 9/11 is an exogenous source of variation in child development, right? Nobody's selected into that group. So I will use that, especially California males born in 2001, as the population that I think would have a different trajectory, consistent with the literature I described. And then I will identify only this group and try to come up with the best expected value of Bailey score and height at 9 and 24 months. Now, if I looked at just December males and plotted their child development, what would be some confounders? Where if I discovered, say, worse Bailey score for just males born in California in December? Susan? Season, sure. So there's strong seasonality in a variety of birth outcomes. Preterm birth happens to be more common in Septembers. So just for example. Yeah, Katie?
Racial and ethnic makeup of California?
Sure, racial and ethnic makeup in California. Okay, such that maybe more or less children in December would have been born to a certain race or ethnicity. Okay. So if I gave you 20, 30, 40 minutes, you'd probably come up with some more. And what Diff and Diff and Diff tries to do is to get rid of all of this by deriving an expected value using 3 comparison groups. It's essentially kind of trying to find three control populations that deal with seasonality, unique California effects, and other factors. All right, so I'll walk you through it. The coefficient, so the theta here is essentially the coefficient on December males born in California. Right? That's the child development I'm looking for. How do I specify it? Well, first of all, I don't know if there's something unique to California males. So I want to take the child development trajectory of December males versus January and August. I get rid of September, October, November, because that's after 9/11, but kind of a washout period. Right? So that's my first difference. To get rid of any kind of unique California effect of males across month. Still doesn't deal with season, though. Second difference. I say, well, my hypothesis is sex-specific, right? Because the whole idea of male-female loss. So now I'm going to take out the same difference that I observed in California females in terms of their development. All right? So that's my second difference. And the third difference is I take the difference between December males and January, August males in California, minus difference between California females December, January, August. Third difference is take another state. So that results are not unique just to they're compared to another state. So they have to be specific to California. Because Not all states experience the decline in the sex ratio. All right? So it can't be a generally occurring thing. Just like, oh, well, that just happened everywhere. So the findings, essentially what this tries to do is rule out confounding due to season, California, any effect that's general across sex, and any effect that's general across place. So the idea is what you're left with is a unique effect of being in that December male 2001 cohort on development. Okay.
So your first California data were from data that you have been working with on a bunch of other things, right?
Yeah.
Here you've got the whole nation. And you talked about Florida being like California in connections to New York, for example. So I guess I don't understand, given that you've got all the states, why it's just California versus everything else.
The what I didn't talk about is that I did that analysis as well in terms of other states that could be affected. There were relatively few, and you brought up Florida. I will do that next. Florida actually did exhibit a drop in the sex ratio in December, and that would be the next area that I'd look at this. To the extent that, but no other state that we detected when we examined it. We didn't examine all 50, but we looked at ones that were so close to New York, DC because of the Pentagon, and I think some other large states, Texas, we found nothing. There was a null result in the 2001 groups. Pennsylvania, nothing. 2001. So using that as essentially the counterfactual where the sex ratio would have been null holds, except for Florida, and I need to still do that. So that's the next thing. Questions on the framework? All right. And so you can think of it in a regression framework. It's a triple interaction term. Basically, it's Decembers times males times California, and you include in all the other interaction terms. Yeah.
What about like economic differences just from year to year? Like the economy is very, varied, and this doesn't seem to account for that. Like there could be different stressors that year, just specific to that year.
Sure. So ECLSB, like you see, it's only 1 year, right? So there could be unique stressors. To the extent that it would confound, it would have to be unique to California males in December. But, right, so the notion, I would argue that probably the best difference to control for economic circumstances, it would have to affect sexes differentially. And by month, because you're differentiating out females. The validity of 9/11, that's, I think, a larger question of what's the external validity of these results elsewhere. I hope we never have another one to really find out. So it's hard to know in terms of generalizability to other, maybe less severe stressors than that. All right, so here's some descriptive statistics. I'll go through this quickly, just to point out that essentially, even though they measure wave 1 and 2, 9 to 24 months, it's not exactly when you get your 2-year birthday, you don't celebrate it by going to ECLSB and getting interviewed, right? So you have variation in ages, which you then have to control for in your results, right? So wave 1 to 9 to 24 months, you see this is a z-score height for age. Want to point out here, females have higher Baileys than males generally at 24 months. Okay, this is a consistent kind of result. I bring up these two just so you understand the mix of births in California. Over 50% are to Hispanics in California, and most are to women that have a high school degree or less. Now here's the triple D results. Difference and difference and difference. Looking at outcomes at 9 months and 24 months. And the coefficients are just for December males in California. So each one of these rows is a separate regression with a lot of interactive covariates that I do not show. All right? 9 months, here are the 3 outcomes. Height and Bailey, and then I actually dichotomize Bailey according to clinical cut points. If you're in the low Bailey, it's not so good. No results at 9 months. You can read the confidence intervals. Essentially, that's an expression of the standard error. And if those confidence intervals contain 0, no relation. But at 24 months, null with the height, I see a positive relation with cohort membership and Bailey score. So the interpretation is Males in California, born in December, have a 9.58 higher Bailey score, points higher Bailey score, compared to their referent group, those 3 referent groups essentially. Question?
So the N, who were the people that
Thank
were
you for
lost?
bringing that up. I forgot. My reference group here, in terms of the final comparison population, the third diff, this is all other states. So my N goes up dramatically because now I can use all of the ECLSB data as my referent, except for those born in September, October, and November, because those are my washout months. So that's, the N gets up a lot higher than just the N for California. So there were about 1,000 in month 9 and 900 at month 24. So, and this also coheres with this notion of the lowest 10%. We have fewer males born in the lowest 10, fewer males that score at the lowest decile of Bailey.
There's a big drop in the end. Is that attrition?
Oh, from here to here?
Yeah.
Yes. There's
So-
80% of people interviewed, of children interviewed, and parents who were interviewed in 9 months are remaining in 24 months. So you have a 20% drop in
Is
participation.
that concerning?
It does.
Okay.
We will talk about it. So, yeah, great.
So if you back up, that's a 1 standard deviation difference, right? For 24-month Bailey. Didn't I see the standard deviation was about 10? If you go,
Yeah. So let me get to contextualize that.
that's huge.
It's huge.
Yeah.
Contextualize it humongous. So let me show you socioeconomic index, quintiles 1 through 5. The lowest quintile of SES for mother versus the highest quintile. That Bailey difference for your child is the difference that I observe in this cohort. Huge. It's a very big difference. So in terms of interpretation, I'll get to Judy's question, which is a very good one. We have this difference emerging at 24 months. George Farkas has done work on Bailey, and he sees that the disparities in cognitive delay manifest not at 9 months, but at 24 months. So it's consistent with this notion of an emergent disparity in cognition. Logistic regression results are similar. I used a different third difference. I used Texas, and the results were the same. I didn't find anything for height, so mixed support for Culled cohort. I want to show you kind of what it looks like if you're just plotting a distribution. Because in some ways, this story is one of, if I'm arguing culling, I'm saying, well, maybe the males that were at the left side of the distribution, that left tail, were the ones that were culled. Would I observe a kind of truncation of the distribution of cognitive score among those males? So this just gives you, so here's January to August versus December. Left tail, left tail. Okay. Obviously, there's some other stuff going on here too, right? So you can measure the mean, but you could also look at the distribution. This is just one of the 3 differences, but just so you can qualitatively look at this. Here's another thing that I think is fascinating. So I mentioned that women, the girls at 24 months, have on average higher Bailey than boys at 24 months. Okay. Here, boys are actually scoring higher than girls. So not just if they were completely overlapping, that would still be odd because girls should have on average higher Bailey. California females born in December, and California males. So boys should be lower. So you think the counterfactual would be boys here. So they're not only almost aligned, they're a little bit right-shifted. Okay. Something's up in December in California. Now, as ECLSB representative, there's a lot of concerns. So how would selective attrition actually lead to bias? Well, you could tell a story that there's something about mothers who had children to males that were born in December who selectively dropped out, leaving behind children who were better off. So that's the rival. The rival is selection that is specific to a particular month and a particular sex of the child. It is possible. What I tried to do is just put in all of the other race variables and other mechanisms of selection, race, age. Can I eliminate the findings? What if I put in all of these variables on which people might select out of the sample? I tried it saying that first of all, same distribution of births at 24 months to the California birth sample. So I think that's representative to the California population of births. And also, when I included other potential variables on which people might select out, findings are very similar. I also tried to actually explain away the findings by putting up SES and very preterm. So very preterm could mediate the relationship, right? We could actually have better cognitive scores among males because there are fewer very low weight births are born, right? There could have been a mechanism. Strong independent effects, home score very strong, socioeconomic index very strong. Again, not really attenuating the finding.
Also weights, right, that have been designed to compensate for differential attrition.
There's also sampling weights that are designed, and these are all weighted.
These are all weighted?
Yeah, okay. They're all weighted. So what's my interpretation then? I'm sorry, I want a lot of time for discussion, so I'll be quick. This cognitive ability result is really large. I don't think this is the only explanation. I don't think culling really can account for this huge difference. There has to be something else going on. And we can talk about it maybe after. There's some really exciting evidence coming out of Chile that it might be not only that males are lost, but females that otherwise they're conserved. There might be both a sex-specific effect in terms of conserving frail females, so that when you look at the difference between males and females, you get these kind of even larger effects. There's also this other theory I haven't really talked about, which is this notion of developmental plasticity. Didn't even bring it up, but some work from the Great Leap Forward famine seems to suggest that exposure to a slight amount of stressor is a good thing. Not too much famine, but a little bit, so that, because if you're expecting not much nutrition when you grow up, you might do well to be prepared before you're even born in a nutrient-thin environment. So culling and damage perhaps really oversimplify the story anyway. What are some next steps? Further examination. If I have information in New York City, I'll look for it. Look at Texas. There's a variety of other propositions I can test with cohort selection. Also, right now I'm trying not to be hot on the trail on what is actually a chemical that would select out. Can we measure something in pregnancy that actually gauges fetal fitness? And human chorionic gonadotropin is one candidate. In California, we have that information in 65% of all pregnancies in the second trimester, and so I'm trying to figure out if HCG could actually be this filter. What is that line? What is it on which we're selecting? And that would move to this notion of what I call population endocrinology, looking at population movements and hormones. So, to conclude, we have gestation provides this huge opportunity for maturation, but also there's a huge selection process that goes on. And the inability or the failure to account for it might dramatically underestimate a lot of these cohort damages. So I'm not saying that one has to exist without the other. They can definitely coexist. Failure to look at cohort damage, especially as it relates to males, culled cohorts as it relates to males, could underestimate these other effects. And males are sensitive. Study us a little more. There's a lot of theory about that. So thank you so much for your time.